is asked. Now we will start the next topic, which is called as wireless communication. So in this wireless communication, the need was wired communication means systems were confined to a single place. You got the idea. Systems were confined to a single place. You cannot move. Even if you are moving from one network to other network, assuming that you have a laptop. So laptop, what will happen, since your MAC address is not going to change, because MAC address is present, is associated with your network interface card. So your physical address remains same, whereas the logical address, IP address, gets changed. Because if you are in home network, your IP address is different. When you are in office network, your IP address becomes different. So you could move that in what I'm saying, wired connection, you could go, but that was there. So in wireless communication, it was felt that there should be no wiring. Wiring is not required. We should frequently, move from one place to other place. So demand for connecting the devices without the use of cable was increasing everywhere. Because the whole infrastructure was getting confined, people wanted to use it in college campuses, office buildings, and many public areas. So there was a need felt for what I meant to say, wireless connection. Now we will try to compare the architecture. Now this question can be asked in university examination, that compare the architecture between a wired LAN and wireless LAN. So we have to present this entire thing. So the medium, first difference in the medium was, in wired network was a wire, and wireless LAN, the medium is air. Got the idea. In wired LAN, wired LAN, wires were used to connect the hosts, and we have seen in the previous section, right? Multiple access was allowed, or point-to-point access was allowed through the various generations of Ethernet, right? And in a switched LAN, a link layer switch, the communication was between point-to-point and full duplex bidirectional communication. And in a wireless LAN, the medium is air. So here, wired connection, you had point-to-point connectivity. You could allow, what I meant to say, multiple access you could allow. Then you had a link layer switch in wired LAN, and the communication between point-to-point was established, and it was full duplex and all. But in wireless LAN, the medium is air, and signal is generally broadcast. Broadcast in the sense, every wireless, every host that is using wireless LAN, you got the idea, gets the frame. You got the idea. So if the frame is meant for me as a host, if my MAC address is there in it, I'll accept. Remaining all other hosts will drop that, right? So when hosts in a wireless LAN communicate with each other, they are sharing the same medium for multiple access, which is air, wireless LAN. And point-to-point connection between two wireless hosts using a very limited bandwidth and two directional antennas. Earlier phones were having antennas, and that was a rare scenario, because now your phone itself is an antenna, right? In wired LAN, a host is always connected to its network at a point, and a fixed link layer address will be there, right? But in wired LAN, what happens? The host can move from one point to point inside the internet to another point inside the internet, but MAC address remains same, because the link layer address is nothing but MAC address, but the network layer address, that is IP address, will change, because that different network, when you go, it will have different IP address. So MAC address, say if I'm carrying my laptop, if I'm using my laptop at home, it will have different IP address, but MAC address is not going to change, because MAC address is there associated with network interface card. So physical address of my laptop does not change, but the logical address, if I'm taking my laptop there in college, college campus, where if I'm using this laptop, its physical address is not going to change, but the logical address, that is IP address, network layer address, is going to change. So in LAN, in wireless LAN, a host is not physically connected to the network and it can move freely. I mean to say the network is available. We have seen through routers and all, it is possible. Since your phones are also doing the same thing. So you are the same. So the concept of wired isolated LAN, you got the idea, also differs from a wireless isolated LAN. This is the third difference. So wired isolated LAN is a set of hosts which are connected through link layer switch. You got the idea, through link layer switch. And we have seen in various, what I'm saying, Ethernet generations. So we had seen that fast Ethernet and gigabit Ethernet and all. And a wireless isolated LAN called as ad hoc network. It is called as ad hoc network. You got the idea. So in the LAN terminology, so this is where the new terminology, technical terminology was coined, was ad hoc network, to talk about wireless isolated LAN. And it comprises of a set of hosts that will be moving freely with each other. That means in an office, if you are having a phone, you can move either third floor or fifth floor or eighth floor or ground floor, wherever you are, you can use still the network happily. So that was called as ad hoc network. And when you are coming outside the college campus, you are going to your home. Again, there also, if a router is there, you can use freely, going to your bedroom, drawing room, you can go to next floor and all that kind of thing. So here the concept of link layer switch does not exist in wireless LAN, whereas in wired isolated LAN, the concept of link layer switch was there. Now this particular aspect, both the aspects of wired isolated LAN and wireless isolated LAN, you got the idea, is shown in this particular figure. So here you can see this is isolated LAN. You got the idea, where hosts are connected directly to a switch. You got the idea. And here you can see these hosts are not connected to each other. This is a ad hoc network and can move freely within a confined area, So this was there. Now, next we will try to see this. In a wired LAN, could be connected to one other, to another network or an internetwork, such as internet using a router. So this was there. And in wireless LAN, may be connected to a wired infrastructure network and to a wireless infrastructure network or to another wireless LAN. So here, next difference is a wired LAN can be connected to another, wired LAN or another internetwork. You got the idea, using a router, it can do that. But in wireless LAN can be connected to a wired infrastructure network, that is wired LAN, or it can get connected to a wireless infrastructure network or another wireless LAN also, it could get connected, right? So in the first scenario, it is about connection of wireless LAN to a wired infrastructure network, right? And this is what next slide, this scenario will be shown. So the second scenario was a wireless LAN getting connected to what I meant to say, wired LAN or another type of network. So in this case, wireless LAN was referred to as an infrastructure network. Wireless LAN is referred to as infrastructure network. And the connection to wired infrastructure, such as internet and all, was done through a device called as access point. You will see this in the next slide through the diagram. So basically the role of access point, this particular device, was completely different from the role of link layer switch in the wired environment. So link layer switch was to receive the frame and send it to the destination, whereas access point does not have this kind of role, of receiving the frame from one sending host and sending it to the destination. Access point basically acts, if you want to connect a wireless LAN with a wired LAN, So access point is acting as a gluing, what I meant to say, mechanism. Gluing mechanism means it is simply joining a wired LAN with wireless LAN. So it was, acting as a gluing factor, a gelling factor kind of thing. So the communication between access point and the wireless host occurs in a wireless environment, and communication between access point and the wired infrastructure network occurs through this. So here, this is the diagram. Now, here we had the first mechanism where wired LAN was getting connected to wired internet. That was the first scenario. In this particular scenario, you see, this is wireless environment, and this is the infrastructure. Infrastructure means it can be another wired internet, or it can be another wired LAN, or it can be another wireless LAN. Right. So this infrastructure, I am calling all the three. All the three means it could be wired internet, or it could be wired LAN, or it could be another wireless infrastructure network. So this access point is acting as a glue, connecting point. You got the idea? It is connecting this infrastructure, which can be any of these three, to this, right? And this is how the whole thing is supported. Now, what are the characteristics of wireless LAN? Now, this can be asked as a question, that what are the various characteristics of wireless LANs? So there are several characteristics of wireless LAN, but we are going to study only few of the characteristics, right? So first one was attenuation, second one was interference, third is multipath propagation, and fourth one is error. So let us see the first characteristic of wireless LAN, which is attenuation. So the attenuation basically talks of the strength of electromagnetic signal. When it is traveling in air, it goes on decreasing, and at one point of time signal will disperse in all directions, because medium is air. Once the frame is released into the air, it can go in any direction. Copy of the frame goes in any direction, and it may happen that only a small what I mean to say part of, you got the idea, signal may reach the receiver. That means signal gets faded by the time it reaches the destination host. So situation becomes worse with the mobile senders that operates on battery. You got the idea? The battery of mobile sender is low. You got the idea? Since battery can operate only for some fixed amount of time, and if you are trying to send a signal, you got the idea, and the battery is low, the strength of the signal will be low, automatically it get faded, and it will be never received by the receiving host. Now interference was another major issue with wireless LAN. So here the receiver may receive signals not only from intended sender, because now in wireless environment all the what I say, hosts are moving. Right, all the hosts are moving. So this is wireless host, this is wireless host, this is wireless host, and this is wireless host. And there is a signal generated by this wireless host. This signal is generated, this signal is generated, this signal is generated by this, signal is generated by this. So rather I should have used some other color to represent the signal. So this is the signal generated by this host. This is the signal generated by this host. This is the signal generated by this host. And these signals are traveling in all possible directions. You got the idea? This signal is traveling in all possible directions. Similarly, this signal is passing in all possible direction. It is also going in this direction, going in this direction. You got the idea? And this signal is going in this direction, it goes in this direction, it goes in this direction, it goes in this direction. And you can see that means each station is receiving signal from many other, what I mean to say, stations besides the intended sender. You got the idea? Now, if they are using the same frequency band, these will be colliding, and signals will become meaningless. Signals will become meaningless. So here, That's the interference part. Now we had a multipath propagation. Multipath propagation, the concept is something like this, that I have a sender here, you got the idea, and a receiver here. Now what happens, this particular sender has sent the frame, this particular sender has sent the frame, you got the idea, send the signal, this particular signal. Now this same copy of the signal may be received by the receiving host. So he is the receiving host and this is the sending host, and this is the signal. This is the signal. Now since this signal, you got the idea, traverses in all possible direction. So suppose there is a wall. You got the idea, and this signal hits the wall, and after hitting it may go in this direction only. You got the idea. Wall of a building, a tall building is there, it hits the wall, or it may hit there is a, assuming that there is a tree here, there is a tree here, and this signal may hit the trunk of the tree, and it may also get reflected in the direction of the receiver. So copy of the same frame is multiple copy of the same frame is being received. You got the idea. So a receiver may receive more than one signal from the same sender, because this electromagnetic wave gets reflected from various obstacles such as wall, trees, ground, objects, whatever are there. Multiple copies will be there. So this is another characteristic of what I meant to say, wireless LAN. Yeah. So the result is that receiver receives some signals at different phases. Now, when they are hitting, these signals are hitting wall at a particular angle, get reflected at a particular angle. So phase, difference will come. And this will be a problem. When phase difference is there, signal will be interpreted differently. Right. So this, makes the signal less recognizable. So that's about the characteristics. And the last characteristic was something about error, something about error. So now we had seen for detecting the, in wireless networks, error and error detection are expected to be the more serious issues, because I know that a lot of collisions may happen, signal fading may happen, or what I'm saying, multipath propagation is a problem. And we have seen that the measure of what I would say error level was signal to noise ratio. We have seen probably in module 3 the signal to noise ratio. So there you got the idea. If signal strength is more and noise is less, if the signal to noise ratio is high, you got the idea. If the signal to noise ratio is high, indicates that signal strength is very good and noise is very low. Then only signal to noise ratio will be very high, and in that case, um, it is easy to construct the actual data. But if SNR is very low, that means our original signal strength is low and noise is very high. So some low quantity, suppose 1 divided by 10,000 I make, it's a very small quantity. But if I make 100 divided by 2 is a big quantity, 50. So here signal to noise ratio is high, means signal quality is very good, and it can be what I'm saying easily original data could be recovered. But if the signal to noise ratio is low, indicates signal strength is very low, whereas strength of noise is very high. In that case, I will not be able to recover the original data. I could not do that. So this was error. Now, in wireless LAN, most important issue was access control, right? So, how a network, wireless host can access what I meant to say, the shared medium, and the shared medium here happened to be air, right? And CSMA CD does not work in wireless LAN because it is meant for CSMA CD was meant for wired LAN. Why it will not work for wireless LAN? For three reasons. Wireless hosts do not have enough power to send and receive at the same time. So any wireless host cannot send or receive at the same time. It can either send or it can receive. And there is what I mean to say, because of battery problem, because they are battery dependent. So either they can send or they can receive, but not doing the both at the same time. Now, biggest problem here is a hidden station problem, which prevents the collision. Now, in examination, generally this particular topic explain the hidden station problem is asked. So this we will discuss for today, this thing. And distance between the station can be very large, and signal gets faded and it will not be received. So now we will see hidden station problem. Basically, in this scenario, what happens, there are stations, due to some obstacles in the range and all, the stations may not be able to detect. So we shall see this example with what I meant to say diagram. So I'll try to what I meant to say explain it through diagram directly. It will be easier for me, right? It will be easier for me. So now here you can see the range of signal for station B is there, whose range can go, signal can go till this. After this, the signal starts fading. So it becomes meaningless. So in this particular area, it can go till this particular part, and after this it fades, right? And C, the signal can be sent in this direction till this particular area, ovular area, what I have shown, it can send in this direction, and maximum it can reach in this direction, right? Whereas A is in the center of B and C, which can receive signal from both, what I meant to say, B and C, because it is in the range of both B and C. But B signal from B is not directly, heard by C, and C cannot hear the signal from B because they are hidden from each other. Now, what happens in a scenario where what I meant to say, B starts sending signal towards A. You got the idea, towards A. And when the signal was being transmitted, C, because air around it, it is idle for it. It feels that it is free because there is no signal, because the B's range end here, and C is sensing the air in this particular range. So it will feel that, yes, my air is free. So half the way, when the frame has arrived somewhere here, uh, which was signal which was sent by electromagnetic signal which was sent by B in the direction of A was not sensed by C. And when this signal was halfway in the midst, in the direction of A, C felt that the medium air was free. It started sending its frame towards A. Now at one point of time, both the signals from B and C get collided, and A will not understand the signal neither from B or C. So here this is called as hidden station problem, right? Since B and C are not in each other's range, they are hidden from each other, and they cannot see or they cannot sense the presence of signal from each other. So neither B can sense the presence of signal from C, nor C can sense the presence of signal from station B, and both are hidden from each other. So this is called a hidden station problem, right? So if at all it is asked